Good morning or good afternoon to each and everyone. Our next topic, next to the Chris DM topic, is all about data preprocessing. The data preprocessing contains data integration, data transformation, data cleaning, and data reduction. Why do we need data preprocessing? So it says here that data in the real world is dirty. It is also incomplete, noisy, and inconsistent. That's why we need data preprocessing. So incomplete, uh, there are lacking attribute values, lacking certain attributes of interest, or containing only aggregate data. So say for example, the occupation. So there is a field in our database about occupation, and then it is null, or it is incomplete. The occupation of a record has no value, has no, like for example, housekeeping, there is no value for that specific field. So another one is noisy. So when it is noisy, it contains errors or outliers. Like for example, we have data sets like 1, 2, 3, 4, 5, and 100. So it has outlier. Since 1, 2, 3, 4, 5 is parang hindi sila nagkakalayo, yung 100 is malayong malayo sa dataset na to. So it has the datasets has its outliers. So yung yung 100 is masyadong malayo sa mga datasets natin. So it is noisy. And then we have also inconsistent. When we say inconsistent, it contains discrepancies in codes or names. So iba-iba. Like for example, yung age niya nalagay doon na 42. And then yung 42 doon, and then yung record na yon meron din siyang birthday. Pero pag na-compute na yung birthday niya at saka yung age niya, hindi lumalabas na 42 yung age niya. So it is inconsistent. So rating also 1, 2, 3. For example, your grades in my class is 1, 2, 3, and then sa finals na naman, sa midterm 1, 2, 3, and then sa finals A, B, C. So hindi siya consistent. So dapat pare-parehas. So it should be, that's why we need data preprocessing in order for our data sets in our database will be consistent or will be standardized. That's why we need to have the computation of the min-max normalization and the C-score. So incomplete data may come from not applicable data value when collected, different considerations between time when the data was collected and when it is analyzed. And of course, we have also human and hardware software problems or human error. And we have also noisy data, incorrect values may come from faulty collection of instruments, human or computer error at data entry, and errors in data transmission. We have also inconsistent, right? So we have also inconsistent data may come from different data sources. So say for example, we have customers feedback, or we have reviews of customers. So it may come from different platform like websites. We have also reviews in your information system or in your website, reviews from Lazada, reviews from blogs from YouTube blogs. So those are it may came from different data sources. And functional dependency violation, modify some linked data, and duplicate records also need data cleaning. Like for example, my name is in the data set, my name is RP Callejo. Since hindi pa ako married noon, and then ngayon RP Arwejo. So nagiging duplicated yung record ko sa database. So it should be addressed by data preprocessing of databases. So why is data preprocessing important? No quality data means no quality mining results. Quality decisions must be based on quality data, right? Kapag hindi quality yung data natin, of course, hindi tayo makakapag gather doon ng magandang information, right? Ng ng magandang information for decision making process. So duplicate or missing data may cause incorrect or even misleading statistics. Data warehouse needs consistent integration of quality data. That's why we have data preprocessing, so that yung data na pinapasok natin sa enterprise data warehouse natin are standardized yung format niya. Okay? So data extraction, cleaning, and transformation comprises the majority of the work of building a data warehouse. Okay, so it takes effort, it takes time for data cleaning and data preprocessing. So we have the major tasks of data preprocessing. We have the data integration, data transformation, data cleaning, data reduction, and data discretization. So the first one, data integration, it is the integration of multiple databases, data cubes, or files. So you will have, or you will decide where to collect your data, or from multiple databases. So it might be from websites or from customers' feedback form, and others. So we have also data transformation. So in the data transformation class, we have to normalize our data by the use of the min-max normalization and different computation techniques. And we have data cleaning. Data cleaning means we have to fill in missing values. So ano yung missing values na yon? Ano yung dapat na ilagay? So smooth noisy data, identify or remove outliers. Yun nga, yung sinabi kong outliers kanina, masyadong malayo doon sa form ng mga data sets natin. Like for example, yung 1, 2, 3, 4, 5 and 100. Yung data sets natin na mga yon, yung 100 is the outlier kasi masyadong malayo sa dataset, sa ibang dataset natin. We have also data reduction, obtains reduce representation in volume but produces the same or similar analytical results. And data discretization, part of data reduction but with particular importance, especially for numerical data. Okay, so we have here so the data transformation includes the data binning and data encoding. So we have smoothing, the removing of noise from data, and aggregation, summarization, data cube construction, and generalization, concept hierarchy, climbing numeric values for age or youth, adult, senior, and normalization is scaled to fall within a small specified range. So normalization includes the min-max and the z-score. And attribute or feature construction, new attributes constructed from the given ones. So let's have the data transformation for normalization. We have the min-max normalization. The statistical formula for min-max normalization is equal to the value 1 is equal to the first value, which is 73,000 minus mean. Okay, the mean or the minimum value of the data sets divided by the maximum value minus the minimum value multiplied by the new max minus new mean plus new mean. Okay, so like for example, we have an example here. Let income range 12,000 to 98,000 normalized to 0 to 10. So take note class that in min-max normalization, the values for the computed normalized data will has the has the range of 0 to 1. So like here we have, okay, 0.709 yung yung na-compute natin na new value. So 73,000, so the first digit that we have here is 73,000. So it has been written here. So meron tayong 73,000 minus 12,000. Since 12,000 class is our minimum value for our data set, and yung range niya is 12,000 to 98,000. So yung 12,000 is our minimum value, and then divided by 98,000 minus 12,000 times 1 minus 0 plus 0 is equal to 0.79 or 709. So that is the min-max normalization, or the computed value for the new normalized data for our 73,000 is 0.709. So likewise in our data sets, so ganun din yung process na ginawa natin. So in 80,000, the old data, 80,000, it becomes 0.791. And then we have 14,000, it becomes 0.023, and 58 to 0.535. Okay, so we have another example of min-max. So assuming that we have the problem, the sample problem for the min-max normalization. So we have the marks for the min-max, assuming that this is our data set. So 5, 10, 5, 6, 10, 15. So this is our marks or our data sets. And then we will compute for its okay, I will share another document para mas malawak kung saan mas ano yung board natin na gagamitin. Okay, so we have here a data set. Our data set, 5, right? 6, no, not 7. 5, 6, 10, 10, and 15. So we have to compute for its min-max normalization. So in computing the min-max normalization, we have the formula value is equal to the value minus mean, right? All over it's the maximum value, max minus mean. And then multiplied by the new max minus new mean plus new mean. So in the standard for the new max and new min will always be 1 minus 0 plus 1. Okay? And then we have here the value. What is our first value? We have 5, right? Minus its mean. Mean is 5. Based from our data set, the minimum value for our data set is 5. And then the maximum value is 15 minus 5. Okay, so let's compute. 5 minus 5 class is equal to 0, right? 0 all over 10. And then 1 minus 0 plus 1. And then we have here 0 divided by 10 is equal to 0 divided by 10 is equal to 0, right? 0. 0, and then times multiplied by 1, it is still 0. 0 plus 1. So, no, 0 plus 0 pala yun. So, 0 plus 0 is equal to 0. So, the new value for our data set here, class 4, 5, this is the mark. And the new value is 0. So, we have another one, 6. What about 6? So, in 6 class, we have to convert 5 here to 6, right? Yung 6 natin. Yung 5 kanina naging 6. And then, yung 15 because it is the highest value. So, palitan natin yun ng 6. So, 6 yung value natin. 6 minus 5 is equal 6 minus 5 and then plus 1 minus 0 plus 0. So, ganun pa rin yung formula natin. Let's just transform the value into the new mark. So, we have here, 6 minus 5, magiging 1 yan. So, magiging 1 over 1 over 10 or 1 divided by 10 is equal to naging 0.1. And then we have times 1 because 1 minus 0 is equal to 1 and then plus 0, 1. Okay, 0.1 times 10 is equal to 0.1. So our new value here is 0.1. For 6 is 0.1. Okay, another one, we have the 10 value. Okay, mag-erase muna tayo, class. Let's erase the computation. Okay, so we have here another value. So it is equal to 10, right? Equal to 10 minus the mean is 5, max all over 15 minus the mean. New max is 1, new max is 1 minus 0 plus 0, right? And then 10 minus 5, of course, 5 over 10. So, magiging 0.5 times 1. 1 minus 0 is equal to 1 plus 0, 1. Okay, so we have 5 divided by 10 is equal to 0.5 times 1. So, it becomes 0.5. So, then for the new mark of 10 is equal to, or the new value for 10 is equal to 0.5. And then we have another one for 15. Okay, so let's erase again. So for 15 class, for 15, the value for 15 is equal to 15 minus the minimum value, and then the max value 15 minus 5. So it is equal to times 1. And then 15 minus 5, 10 over 10. So magiging 1 times 1. So 1 times 1 is equal to 1. So the new value for 15 is equal to 1. So this is our new normalized data. So 5 becomes 0, 6 becomes 0.1, 10 becomes 0.5, and 15 becomes 1. So that that is the computation or calculation on how to normalize data using the min-max normalization. So take note, class, that the formula in computing min-max normalization is equal to the value is equal to value minus mean divided by max minus mean times multiplied by the new maximum minus the new minimum times new min. Okay. So let's proceed to another. We have the C-score. Stop share ko muna. So we have here C-score standardization. So the formula in C-score standardization is equal to the value. C-score is equal to the value minus the mean. So mean, the symbol of mean is this one, all over standard deviation. So yung standard deviation natin parang alpha, yung ano niya, yung symbol niya. So let the mean is equal to 54,000 and the standard deviation is equal to 16,000. Then so let's transform our data sets. So this is our data set class, data set 73,000, 80,000, 14,000, and 58,000. So our data sets class are those values. So the first value that we have is 73,000, right? So it is here. Yung 73,000 minus ano yung mean natin. So the mean is 54,000. Yung mean natin is 54,000 divided by 16,000 plus 16,000 is the standard deviation of our data set. The standard later on magma-manual tayo mag-compute ng standard deviation. 73,600 minus 54,000 divided by 16,000 is equal to 1.188. So that is our new standardized or normalized data. So for 73,000 class, the computed is 1.188, and then for 80,000 we have 1.625, 14,000 we have negative 2.5, and then for 58,000 0.250. So that is the C-score standardization. So let's have another example. Let's have another example here. We have data transformation. So we have here considering the given data. So this is our given data class. Ito yung given data natin. Data set 29,000, 51, 10,000, 38,000, 16,000, 46,000, 74,000, 85, 18,000, and 42,000. So what is our minimum value for this data set? We have 10,000, right? So the minimum value is 10,000, and then the maximum value from our data set is 85,000. So take note that you will be using constant value for new min. Okay, new min is a constant value. It cannot be changed. So 0 and new max 1. So okay, so just like what I've told you a while back, new min dapat 0 to 1 lang yung computed value natin. So yun yung constant value for the minimum and the maximum values for the min-max normalization. For the C-score, sorry, nagkamali ako. C-score dapat yung inano kong example, min-max pala yun kanina. So we have here C-score. So just like what I've told you a while back, in getting the C-score, we have to first get the mean and then the standard deviation. So we consider here the data set 2,900, 5,100, 1,038, 1,646, 7,400, 85, 8,500, 1,800, and 4,200. So first, we have to consider getting the mean or the average. So when we say mean class, it means this is the average of the data sets. So we have, in computing the mean class or the average in our Excel, average lang, di ba? So yun yung kagandahan ng average, yung paggamit ng Excel. So ilalagay lang natin yung min-max niya, lalagay lang natin yung data sets na or built-in function na average, mako-compute na niya yung mean. So dito class, ang gagawin natin, compute the summation of all the data divided by the number of data set. Ilan ba yung data set natin? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10. So 10 yung nasa baba. And then summation of all those data sets. Yung data set natin na to. So we have the summation of all these data set 40,900 divided by 10. So the mean now, the computed mean is 4,009. So then for each number, subtract the mean and square the result. So we have here, we have the first value, 2,900. So based from our data set, 2,900 minus 4,090 squared is equal to 11,000 or negative 1,190 squared. And then equal to 1,416,100. So that is the squared of the mean for the first value. So just like the first value class, we have to compute also other values, the mean and square of the result. So we have here for other numbers. So our first value, we have 1,416 or 1 million rather, 1,416,100. So summation of all the squared difference. So masasum lahat ng mga squared difference kanina and then multiplied by the data sets. And the data set and the mean of the computed value is equal to 5,418,900. And take the square root of the mean. So you may use calculator here. Square root of 5,418,900 is equal to 2,327.85. So this is our new mean. So the standard deviation is equal to 2,327.853. And then for computing the C-score, so that's the first process, right? So the first process is we have to find first the mean and the standard deviation. And after computing the standard deviation and the mean, we have to compute the formula in getting the C-score. So the value is equal to the value minus 4,090 divided by the computed standard deviation, which is 2,827.853. So it becomes, so 5,500 minus 4,090 is equal to 1,410 divided by the standard deviation 2,827.853 is equal to 0.605. So the first value for our data set 5,500, the new value is 0.0605. So likewise, in our second data class, second data set, which is 1,410. So let's transform it to our formula. 1,410 minus 490 is equal to negative 2,680 divided by 2,827.853 as the standard deviation, and it is equal to 1.151. So let's write again. Let's write the new value for 1,410, which is negative 1.151. Okay, so we have here another the last data set. For our last data set, we have 8,000. So yung 8,000 nag-transform tayo dito ng value minus 4,090. So yung 4,090 class is the mean divided by the standard deviation, which is 2,827. So 8,000 minus 4,090 is equal to 3,910 divided by the standard deviation, which is 2,827.853. So in here class, yung magiging C-score natin is 1.679. So that is our new value for 8,000, which is 1.679, or ra-round up natin, magiging 1,600. So that is the C-score. So in order for us to compute for the C-score, we have to find the mean. Yung mean muna yung kukunin natin, and then the standard deviation. So yung mean, when we say mean class, it is the average of all data sets. Yung standard deviation naman class, the square root or the square root of the squared mean of the data sets. So ganun yung C-score natin. So mas mahirap yung C-score standardization natin kesa yung min-max normalization. Pero okay lang. So ganun yung ibibigay kong activity or activity later on, min-max normalization and C-score. Okay, so the next one we have binning. So yung binning naman class, it is the process of transforming numerical variables into categorical counterparts. So say for example, yung numerical numbers kasi siya, yung categorical maybe it is in alphabetical order. So an example is to bin values for age into categories such as 1 to 18, 18 to 49, and 49 or onwards. So the bin is 1 to 18. So tatlo yung binning niya. So 1 to 18 yung mauuna, first bin, second bin, and third bin. So this one, it consists of 1 to 18. Yung isa, yung second bin 1, 18 to 49. And the last one, 49 onwards. So parang nag-aano lang kayo, nag-separate ng mga data sets. So kapag malalaki yung data sets natin, you consider binning or yung pagse-separate ng mga data sets natin is 5 to 10. Kapag mas maliit lang, like eto, 1 to 18, 18 to 49 and onwards, pwedeng tatlo. So 3 to 5 data set yung binning natin. So rationale, some data mining algorithms run better on categorical data, like for example, decision trees. So yun nga, yung sinabi ko na doon sa inyo, decision tree class, yung decision tree natin, okay, yung decision tree natin, pabaliktad, right? Imbes na yung roots niya nasa baba, siya nasa, yung roots niya is nasa taas. So, pabaliktad siya. So, ganyan. Parang decision. So, allows easy identification of outliers. We have two types. We have the equal width and equal depth. So, equal width is the distance partitioning, divides a range into n intervals of equal size. So, when we say n intervals, these are the binning of equal size. Uniform grid, if A and B are the lowest and the highest values of the attribute, the width of the intervals will be the width is equal to the bin minus A divided by the number of intervals. Equal depth frequency partitioning divides the range into intervals, each containing approximately some number samples and good data scaling and outliers. So, yung equal width natin, it divides partitioning into equal size. Yung equal depth naman or equi-depth partitioning, it divides the range into n intervals. Okay, so we have data cleaning. What is the importance of data cleaning? Data cleaning is one of the three biggest problems in data warehousing, right? Because data cleaning involves many different tasks like fill in missing values, identifying outliers. You have to fill in many values in your data sets. So yun yung mahirap, yung pag-fill in ng mga values, and then identifying outliers and smooth out noisy data, correct inconsistent data, and resolve redundancy caused by the data integration. So, missing data is not always available. Many tuples, when you say tuples class records, have no recorded value for several attributes such as customer income and sales data. Missing data may due to equipment malfunction, inconsistent with other recorded data, data not entered due to misunderstanding, data may not be considered important, not registered history or changes, or missing data may need to be inferred. So, how to handle missing data? Ignore the tuple or ignore the record. Usually done when class label is missing, assuming the task is in classification not effective when the percentage of missing values per attribute varies considerably. Fill in the missing value manually, tedious plus invisible. Data imputation, fill it automatically with global constant, unknown. So you can fill in with unknown or a new class. Okay? So noisy data, noise, random error, or variance in a measured variable. So we have here incorrect attribute values made due to faulty data collection, instrument data entry problems, transmission, technology limitation, inconsistency, duplicating the record, incomplete data. So those are the problems of noisy data. Okay, so there are ways on how to handle noisy data. So just like what I've told you a while ago, we have binning, regression, clustering, and combined computer and human inspection. So that is data preprocessing has really the most tedious and major task in the extract in data mining class. Okay, so we have here sorted data for price in PHP. We have for this data set. And then, bibilangin natin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, maybe mabibin natin 12 yung data natin. So, okay lang na i-bin natin sa tatlo. So, for bin 1, we have 4 to 15, bin 2, 21, 21 to 25, then 26 yung bin 3. So, that is equi-frequency or equidepth means. Okay? So, smoothing by bin means, eto, yung min niya, yung kukunin. Yung bin 1, 9. Yung min ng 4, 8 to 9, 15, 21. Yung min nito is 9. Kaya 9 yung nalagay dyan. And then, eto naman, yung 21, 21, 24, yung min niya is 23. Kaya 23 yung nilagay dyan. And then, the third one, 29, kasi yung min niya is eto. Yung min ng dataset na to, 25, 26, 20, 8, 29, and 34 is this one. Okay, so aggregation, we have data reduction. Data may not be balanced, so we need data reduction. Example, medical data sets with 9,900 negative cases and only 100 positive cases. Solved by unsampling, randomly select tuples. So random lang yung pagse-select from minority class to increase samples. So kumbaga random. Meron dito or yung pagsasample is kahit ano na yung kukunin niya from the datasets. So downsampling, random select records from majority class to decrease samples. So pabaligtad siya. Yung upsampling from minority to the increase. Etong downsampling naman from majority to the decrease samples. So aggregation means combining two or more attributes or objects into single attribute. The purpose, data reduction, change of scale, and stable data. So sampling means the main technique employed for data selection. It is often used for both the preliminary investigation of data and for the data analysis. So yun na, yung sampling, yung pag in data gathering, you have to have your data sampling. The statistician sample because obtaining the entire set of data of interest is too expensive or time consuming. Sampling is used in data mining because processing the entire set of data of interest is too expensive or time consuming. Kasi kapag yung buong data yung ipaprocess natin or isa-sample natin, then magtatagal or masyadong matagal yung pagpaprocess ng sampling or yung sampling natin sa data mining. Kaya kailangan ng sampling. Okay? Kasi baka masyadong matagal yung pagpaprocess kapag hindi tayo nag-sample. So the key principle of for effective sampling is the following. Using a sample will work almost well as using the entire data sets if the sample is representative. A sample is representative if it has approximately the same property of interest as the original set of data. Kaya dapat yung sample natin, we consider everything in our dataset, original dataset. So kung kukuha tayo dito sa data mart na to, or yung doon sa part na majority class, dapat meron din tayong dataset doon sa minority. So random lang siya. Okay, we have types of sampling: simple, random sampling, sampling without replacement, sampling with replacement, and stratified sample. So when we say random sampling, there is an equal probability of selecting any particular item. Sampling without replacement, removed from the population. Sampling with replacement, objects are not removed from the population as they are selected for the sample. And stratified, split the data into several partitions. Then draw random samples. So it has random, or it has partitions. Okay, so pero kung titignan natin plus yung sampling natin, kapag mas marami yung sampling natin, mas parang accurate yung magiging output natin. So that's it for today, class. I will be giving you this assignment. Yung assignment natin will be this one, computing about min-max normalization. This will be your activity. For the min-max normalization and the C-score. So later on, class, I will upload it into our Google Classroom. Okay, so goodbye, class.